AP. Today's section's on 2.5. We're going to look at implicit differentiation and how it differs from what you already have learned about derivatives. Your learning targets are, number 1, I can distinguish between functions written in implicit form and explicit form. We're going to learn the difference between those two. Learning target 2, I can use implicit differentiation to find the derivative of a function, and that is the sole purpose for this section. And number 3, I can find derivatives at specific points and then write tangent lines to the graphs using that. So when we're doing number 3 and writing a tangent line, writing an equation for a tangent line, remember we want to use point-slope form, so we definitely need a point and we're going to need a slope. Explicit form is where y is a function of x. Equations are solved for y. This is what you have been used to. So, for example, in Algebra 1, when you saw equations like y equals 5x, it was already solved for y, and it was called explicit. Another sample here, y is equal to 3 over x. That's explicit as well for the sole purpose of it being solved for y. We know that from Algebra 2 and Pre-Cal that this is a rational equation, and so the graph is going to look like that. Some functions can be written in both explicit form and implicit form as well. Implicit form is when your equation or equations where the y is not written as a function of x. Basically, it's not solved for y. So an example of this, all kinds out there, but an example would be y divided by x is equal to 5. So if an equation is not already solved for y, it's called implicit form. Example 2, xy is equal to 3. Now, with the two examples that I've just given you, we can actually take, however, the equation y over x equals 5, and we can solve it for y very easily by getting rid of the divide x. Since it's being divided, we would do the opposite and multiply both sides by x. And then we would end up getting y is equal to 5x. And so, like I said before, sometimes we can take implicit form equations, easily solve for the y, and then turn it into explicit form. Same deal with my example 2. Here, I can take the problem xy equals 3, solve it for y, and notice that the x is being multiplied by y, so I would have to divide through by x. And then I would get y is equal to 3 divided by x. Okay, so sometimes the problems can be written in both forms. However, there are problems out there, some functions that can only be written in implicit form, and so when we have questions like that, that's why we need to know how to do implicit differentiation. So let me give you a quick sample of one where some functions can only be written in implicit form. Let me write that out. Making sure I didn't have it on the next slide. So an example of that would be x to the third minus 5y to the second plus 10y is equal to 3. That's an example of one where solving for y would definitely be difficult because there's actually 2 of them, and we got an x to the third. And so this is a prime example of why we need to learn implicit differentiation, because, like I said, sometimes they give me equations that I can't transfer from one form to the other easily. When you can solve an equation for y and change it from implicit to explicit form, please do so, and just find the derivative using the past rules. So by all means, when you look at a problem, if you know I can easily solve this equation for y and change it from implicit to explicit, go ahead and do that. It will make the problem easier, and then just find the derivative using the past rules that we've been learning in this unit. However, some equations are difficult to solve for y, like the previous example I shared with you. So you're going to write explicitly. Some equations are difficult to solve for y and write explicitly, so we use what's called implicit differentiation. And so our main goal is to differentiate, find the derivative with respect to x. So when you have terms involving x, then you just find the derivative as usual. That's the easy part. When you differentiate terms with the y, you must use the chain rule. So when you're differentiating with respect to x, and you have terms that have the same letter in it, then you're just going to find the derivative as usual. But then if the problem says differentiate with respect to x, and they throw in a different letter on you, then you must use the chain rule. Okay? Alright, so let me show you what I'm referring to with that last statement. Remember the notation from the past, dy dx means find the derivative of y with respect to x. What you're really going to need to pay close attention to is this. So when this is on the bottom, that's with respect to x. They'll give you a problem here. Let me just throw in an x to the third. And so this is saying find the derivative of y with respect to x of x to the third. Well, because this notation and these are the same letters, then, and when they match, you're going to differentiate as usual. So the answer to this is a simple power rule. Just 3 times 1 is 3, and then x to the second. Okay, so that's an example of the first statement here. Okay, now take a look at this one. Find the derivative of y with respect to x of y to the third. Please notice that with respect to x, there's not an x in the problem. And so when you differentiate terms with a y or with any other letter, that should really say, that's different than your x, you have to use the chain rule, especially if that's what you're trying to find. Okay, so when terms do not have the same variable, please use chain rule. When this does not match this, please use chain rule. But what you're going to do first is you're just going to differentiate the outside. So treat it like it were x at the beginning. 3 times 1 is 3. Y to the second. And then you'll need to do y prime. Find the derivative with respect to y. But I usually just write it like this. Okay. Alright, so that's the new part. Let me go over that one more time here. Find the derivative of y with respect to x of y to the third. Since we're finding it with respect to x and there's not an x in the problem, we have to use the chain rule, meaning we do the outside first. 3 times 1 is 3. drop y down, whatever this is, and then decrease the power by 1. But then because it's different, we have to do the derivative of y with respect to itself, and that's going to be y prime, dy. Okay, and sometimes they'll write, you'll see the textbook do this as well. You could have said 3y squared times dy dx. Okay, so both of these mean the same thing, but I feel like, in my opinion, that when you're solving problems and you're using implicit differentiation, for me, I like it written this way, because I can find this a lot faster in the midst of a long problem. Okay, but again, that's just my opinion and my preference. Okay, so here are our steps that we're going to follow today when we know that we have to use implicit differentiation. In other words, we know that the problem cannot easily be solved for y, and we're going to have to find the derivative anyway. You're going to differentiate both sides of the equation with respect to x. So you have to do both sides with respect to x. Then, after you do that, you're going to collect all terms involving dy dx, or y prime, on the left side. Okay, so you're going to collect terms with y prime on the left side of the equation. Next, you're going to factor the dy dx, or y prime, out of the left side. So you're going to factor y prime out of the left side. And then you're going to basically just end up solving for dy dx, or y prime. So we're going to take a problem, we're going to derive both sides with respect to x. We're then going to put all terms that have that y prime, like terms, on the left side of the equation. We're going to factor out y prime to get it by itself so we can solve for it. Alright, so let's differentiate with respect to x. Example number 1, d dx of x to the 7th. Find the derivative with respect to x of x to the 7th. Since this is the same variable as this, we can just continue like we did before with the power rule. So 7 times 1 is 7, drop my x down, decrease power by 1. And we don't need to use the chain rule. Okay, so that was a quick example of power rule. The easiest derivatives you'll see. Okay, example 2. Find the derivative with respect to x of y to the 7th. Because these do not match, we're acting as if it were x first, so we're going to do 7 times 1 is 7, drop this letter down, decrease power. Then we're going to have to do the inside derivative of this, and with respect to x. So we're going to do dy dx, or just times y prime. So this would be your complete answer. Okay. Alright, example 3. Find the derivative with respect to x of 2x plus 4y. Okay, notice that these, obviously there's a polynomial here, two terms, so we're going to do derivative of each piece. This step you do not necessarily have to write down. I'm just making sure I show everything in the video. Make sure your eyes are following me, you know where I am. So we're doing the derivative with respect to x of the first piece, and then we're going to do the derivative with respect to x of 4y. Okay. Alright, so let's check this out. These are the same. Derivative with respect to x of 2x is just 1 times 2 is 2, and that would be x to the 0, which is just 1. So derivative here is just 2. Drop a plus sign down. Find the derivative with respect to x of 4y, different variable, and so I'm just going to do the derivative of the 4y first, and that's just going to be the coefficient 4, or constant 4. And then chain rule, because these are different, I'll have to do dy dx notation or y prime. So this is my answer for question 3. Alright, let's do a different scenario. Number 4. Find the derivative with respect to x of xy squared. Okay, now what you want to notice here, obviously, is there's two variables involved, and so this is a classic example of product rule for derivatives. I'm going to go back and remember that I take the derivative of the first times the second plus first times derivative of second, and that's the order we'll go in. Alright, so let's start off with derivative with respect to x of the first. Here's the first. Derivative of x with respect to x is 1. Derivative of the first times the second. So then you'll just do y squared in parentheses. Product rule has a plus sign in between. Now, the second part of the rule is to write down the first term, and then multiply that by the derivative of the second piece, which is y squared. Now again, because these are different, it's like you're doing a chain rule. You have to do 2 times the 1, 2, y to the first, and then the derivative of the y with respect to x is going to be dy dx or y prime. So let me rewrite this. So the final answer, a good way to write it would be y squared plus, and I always try when there's a number involved, obviously, to put it in front. So I'm going to do a 2xy y prime, and also try to put the letters in alphabetical order. So this is a good answer. Or you could do this. I shared this a minute ago, just reminding you. Instead of the y prime, you could write it this way. I'm sharing that because some versions and some textbooks, and ours does this, will write it that way too. Alright, keep it rolling here. Number 5. Find dy dx given y to the third plus y to the second minus 5y minus x squared is equal to -4, and find the slope of the graph of that equation at the point 1, -3. Okay, so what we need to notice, obviously, here is that this equation is definitely not solved for y. It is in implicit form from the earlier notes, implicit form. This problem is not easy to solve for y since I have 3 terms with y. Okay, so it's not as easy to solve. So that's why implicit differentiation is important, especially in this scenario. So what we're going to do is find dy dx using implicit differentiation. Okay, and we're going to have to remember that you do the derivative of each side. So that's why I'm choosing to rewrite it, because I didn't do that a second ago. So this is a good way to show this first step. Find the derivative of y with respect to x of the left side of the equation, and do the same thing on the right side of the equation. Alright, so notice on the left side we have 4 terms. Okay, they are separated with plus and minus signs, which is good. Each term has a single letter in it, so I don't see any product rule going on. So that means I can do each individual term. Find the derivative of y with respect to x of y to the third. We're focused on this one first. That would be 3y to the second. And I'm going to have to do y prime again because the letters here don't match. Then plus. And now I'm doing the derivative of this piece. And that's going to be a 2y. And then chain rule dy dx or y prime. Then I'm going to do the derivative of y with respect to x of -5y. So I'm going to drop my -5 down. That's the derivative of this piece. And then multiply that by y prime. Chain rule. And then I'm going to do last term over here, derivative of y with respect to x of -x squared. These do match. So I'm just going to say -2x, and I don't have to do the chain rule because of that, these letters matching. Equals, and then on the right side, the derivative of y with respect to x of a constant is going to be 0. Okay, so I've done the derivative of the left side, derivative of the right side. The next step in the process is to kind of group like terms together, making sure that you keep your dy dx on the left side of the equation. As you can see from my 4 terms, the first 3 of them have y prime. So the next step would be for me to transpose the -2x. And don't mistake that for a 1, because I've had students do that in the past, so be really careful. Try to write it in a way that it's clear to you and to me. Maybe we should be arching it a little bit. Alright, once we group like terms, then we're going to factor out, since all of them have y prime. We're going to factor that out as a GCF. So y prime times 3y squared would give us back the first term. Y prime times negative or positive 2y would give us the middle. And y prime times negative 5 would give us the last. And now you can see hopefully why we factored out the y prime. We're trying to solve for it. So now it's separated from these three terms. This trinomial is being multiplied by that. So we're going to do the opposite of multiply. We're going to divide. Okay, so keep it like this together. That cancels. And here's what our dy dx stands for. Alright, so we got the first part of the directions accomplished now. We did this part. You can see the steps that it took, and now we're going to focus on finding the slope of the graph at 1, negative 3. So you're going to now take this equation and find the derivative at this location, 1, negative 3. And so you're going to obviously put the 1 in for x and the negative 3 in for y. So y prime for dy dx is equal to, we're looking for slope right now at that specific location. And I really should have written it this way. So let me backtrack here. So we're going to do 2 times 1 divided by 3 times negative 3 squared plus 2 times negative 3 minus 5. So the top's 2. Negative 3 squared is 9. 3 times 9. Um, 2 times negative 3 is just negative 6. And then drop my negative 5 down. So 27 minus 6 is 21. 21 minus 5 is 16. And so when you reduce that, of course, 1/8. So the slope of the slope at the point 1, negative 3 would be 1/8. And so that would be your second answer to the directions. And try to remember what that means again, that when I take this problem right here and I literally graph it, if I had a visual for it and a graph for that picture, and I went to the location 1, negative 3, the slope actually turned out to be 1/8, meaning at that location, the graph of the tangent line would only rise like up 1 and right 8, up 1 and right 8. So kind of keep that in mind. When you're finding slope in calculus, of course it's derivative, but the slope indicates the slope of the tangent line that intersects that graph at this location. Okay, let's try a few more. Let's try about 3 more. We got kind of different scenarios going on here. So, number 6. And your problem is find dy dx and the slope at the point square root of 2, comma, negative 1/2, and the equation is x squared plus 4y squared is equal to 4. And so this is definitely implicit. I could solve for y in this one. It might take me a few steps to get there, so I'm going to choose not to. And I honestly think, well, when I did solve for y, it would be an equation that's kind of messy anyway. So finding the derivative of it might be just as difficult as finding the implicit differentiation or implicit derivative. So we're going to practice what we're learning. We're going to do dy dx. Of x squared plus 4y squared. Notice my notation because I want you guys to model the same thing. Okay. Find the derivative of y with respect to x of x squared. That would be 2x. Find the derivative of y with respect to x of 4y squared. That would be 2 times 4, 8. Y to the first times the chain rule, y prime. Equals. Derivative of y with respect to x of a constant is 0. And then we will gather terms with dy dx on the left side of the equation, and we'll transpose anything that does not have y prime. We will then solve for y prime. 8y is being multiplied, so we will show division. And I'm going to go ahead and simplify this. Negative 2/8 is negative 1/4. So this is the best answer here. That's what y prime is equal to. And then we're going to go back. We got the first part. We're going to go back and find the slope at that location. So y prime at the point radical 2, comma, negative 1/2. Okay. All right. So let's see. It's going to be negative. The x is radical 2 divided by 4y. So 4 times negative 1/2. And so this is going to be negative square root of 2 over negative 2. Okay, and that's going to be a positive. Alright, so there's my slope at this location on this graph. Now, from Algebra 2, and sometimes we cover it in honors and some years we don't, and I'm not sure about the year you had honors too, or if we got to it or not, but just based on the way this equation looks, I have an x squared and a y squared. So when I have two variables that are squared, it's going to be a conic section. Conic section are either parabolas, circles, ellipses, or hyperbolas. And a quick way to tell if it's a ellipse, and this one is that both the variables are squared, first of all, and both the coefficients are different, and they're positive. And so this is an ellipse. Now, without getting into all the features of it and getting a good, perfect graph, remember an ellipse is one, okay, sorry about that, is one that is a stretched circle. So it either could look like that, or it might look like this, like up and down, okay? But in either case, at the point radical 2, which is roughly 1.14, comma negative 0.5, at that location, if I were to draw the tangent line, the slope would be this. Okay, but I just wanted to go over this because I know on the AP exam they're going to put questions that are conic sections and just expect you to know the graphs of it without having to take your time, waste your time basically, solving for y, using your graphing calculator, all that good stuff. Also, it could be a non-calculator question, meaning that you're just going to have to recognize what it is and then kind of visualize the shape in your head. Okay? Alright, just kind of wanted to go over that before we moved ahead. On number 7, let's try to do one with a trig. Let's do sine y is equal to x. And let's do a slope at square root of 2, comma, negative 1 over the square root of 2. Let's do that. So we're finding the slope at this location. Obviously this one's not solved for y. There's no mathematical way of getting rid of the sign off the y, so this is definitely one that is in implicit differentiation and has to stay that way. Okay, I mean implicit differentiation is a have to here. Alright, so we'll start with dy dx of sine y. We're going to do the chain rule here. Let's do the derivative of sine y first. Derivative of sine is cosine, so cosine of the same variable. And then multiplied by y prime. Right side, find the derivative of y with respect to x of x. That would just be the 1. So in this case, I see cosine y is actually being multiplied by y prime. And so I'm going to have to divide to get rid of it. So please pay attention to like how it's related, of course, to the y prime symbol, and that way you know what algebraic operation to use. Some of these can get a little tricky because there'll be so many terms. So make sure you're staying organized, using parentheses when you need to, so forth. Y prime comes down. It's equal to 1 over cosine x, or cosine y, sorry. And we can change that. We know what 1 over cosine is, so we're going to change it over to secant. And the reason I'm choosing to do that is because I have to find a slope, and I think it'd be easier to do it this way. But you could also give me that. Alright, now let's find the slope at the point square root of 2, comma, negative 1 over square root of 2. Okay, so in this case, like, my derivative is just secant y, so I would just write secant of the y value in order to find the slope. So I'd have to evaluate that. Okay, which essentially means we could go back and say 1 over cosine of that value. Okay, and so in that case you could actually just use your calculator here and convert it to decimal. That might be fastest, and then just use your fraction mixer. On my calculator here. And I'm getting 1.32. I rounded it. Or 1.3154. Because remember in calculus we like to write 4 numbers after the decimal. That's how they like you to round. Okay. Alright. Let's see here. Alright, we'll do one more, and this one's going to be a longer one. Just because the nature of the problem, but also there's so many steps and so many terms. Sometimes they can put all kinds of different rules into one problem. Just to see if you can apply things you've learned from the past. Okay, so we're looking for the derivative with respect to x and the slope at the point 3, 1 of 3 times the quantity x squared plus y squared is equal to 100xy. Obviously, this is not solved for y, and it would be hard or difficult to do so. We're going to do implicit differentiation. I'll left this out. Let's put a 2 here on the outside, so go back and change that in your notes. And this one's longer because there's so many different parts to it, and you can kind of look. Let's try to look ahead here. At this left side, we definitely have a chain rule because we got an outside function 3x squared and we got this inside. This is the u. And so we're going to start with doing the derivative of the outside. So 3 times 2. We'll drop down the inside function. Okay, so this will become a 1 now. And then we've got to, the chain rule says do the derivative of all of this. Well, the derivative of y with respect to x of just this first piece, right here, I'm multiplying all this together, okay? So this will be 2x. And then there's a plus sign, so I'll bring my plus sign down. And then I'm doing the derivative of the y squared with respect to x. So that would be like 2y prime. And just make sure, take a second, make sure you understand where that came from. So 2 times 3, 6. Inside rule, u comes down. That goes to 1. Now you do the derivative of the u, but the u has 2 pieces. Derivative of x squared is just 2x, plus derivative of y squared is 2y prime. Right side of the equation, find the derivative of y with respect to x of 100xy. Notice again, this one actually has 2 variables, so this is a product rule. So the left side was a chain rule, and the right side is a product rule, looks like. Now, what you want to do in this case is don't treat the coefficient as part of the x and the y. I tend to attach it to the first letter, so think of it in terms of like 100x and then times y. That will definitely help. And do that every time. So find the derivative of y with respect to x of 100x times y. Product rule says derivative of the first. Derivative of 100x is 100 times the second, which would be y. Plus sign in the middle. First, which is 100x, times the derivative of the second. Well, the derivative of the second, which is just y, with respect to x, is a 1. So technically that's just a 1. But we do the chain rule on that part as well, since these letters don't match, and that becomes y prime. Okay, so I'm taking care of both sides. Next step is to find all your y primes. I see one there, and I see one here, and we want to put them on the same side of the equation. Alright, but before we do, I think I'm going to go ahead and distribute this to make it a little easier. So I'm going to call this 6x squared plus y squared. And that way we can keep this in one parenthesis. And now I want you to notice before you can't start switching terms. I know I said you have to put the highlighted terms on the same side, but you can't do so until you simplify using algebra. So like looking at the problem that we're faced with, look at the left side right now as I finish this out. Okay, keep an eye on this. We can't just move this over here without having this in the way. And so what you want to do on the left side, you notice there's 2 terms here, 2 terms here, and they're being multiplied. I would go ahead and just distribute. I'd use FOIL. Let's get all these as separate terms before we start transposing. So 6x squared times 2x is 12x to the third. 6x squared times the 2y prime. You gotta be careful here, a lot going on. That's a 12 x squared y and then y prime. Inside is 2x times y squared. And last is y squared times this, which is going to be 2. Y times y squared is y to the third times y prime. And I think when you FOIL it, you can see that, like I said, the terms are all separated now, and it's so much easier to group like terms. So always kind of keep that in mind when you have a problem of this nature. And let me grab my highlighter. So this term, and this term have y prime. They need to be moved to the left side of the equation. So I'm going to keep these two here. It's just a lot of writing. Really hang in there. And then this one comes over here as a negative 100 x y prime. And then this term, and this term that did not have y primes, they need to be on the right side of the equation behind the equal sign. So we got 100y, and this one's going to transpose over as well as this one. So negative 12x to the third. I just always work left to right. And then minus 2x y squared. Okay, I just caught my mistake. Right up here, and you guys at home probably caught this already. That should have been, I don't know why, but I left out my 6, didn't I, as a coefficient? So let's fix this. First, outer, inner. This should have been a 12. 6 times 2. Okay, and then this is also going to be a 12. Alright, that wasn't too bad. I think we got it now. And so that means I need to change, let's see, this term is over here. It should have been a negative 12. This term, I did. This term, whatever that one is, that one needs to be a 12. Alright, let me make sure I'm right now. Okay. Alright, I got it. Now we're going to, after we group all terms with y prime, we factor out y prime. And we copy down the right side. Okay, and so since this trinomial is being multiplied by y prime, we can divide to get rid of it. Just going to do that, and then put it over here. And the next step. Okay, and so now, let's see, all of this is going to cancel, and y prime is equal to 100y minus 12 x to the third minus 12xy squared divided by 12 x squared y, this is messy, plus 12 y to the third minus 100x. And what I'm noticing in this, as I write down the answer here, what I'm noticing in this step is that I could actually have factored out a number, since look at these coefficients. So it's probably best to do that, to simplify it. A number that goes into 12 and 100 at the same time. See, factors of 12 are 1 and 2 and 3. 3 won't go into 100. 4 will. 6 won't go into 100, and 12 won't go into 100. So it's just going to be a 4. We'll factor this out. Same deal on the bottom, so that's going to be nice because then I can cancel these in a minute. I'm going to watch the signs. So these are going to cancel, which is good. And so y prime is going to be equal to the step above. And I'm just going to highlight it. So this is the best answer for that problem. (25y minus 3x to the third minus 3xy squared, all divided by 3x squared y plus 3y to the third minus 25x. And you can see, you were doing it with me, that it took a while. So some of these problems will. If you notice up front, you see a chain rule, product rule, it's going to definitely take you longer. And now to complete it, you need to find the slope at 3, 1. So you'll go back up here and substitute. So 25 times 1 minus 3 times 3 cubed minus 3 times the x value of 3, y value of 1, 1's being squared. Be careful there. Bottom is going to be 3 times 3 squared times 1 plus 3 times 1 cubed minus 25 times 3. Alright, 25 times 1 is 25. 3 cubed is 27, and 27 times 3 is negative 81. We do power here, so 1 and 1 times 3 is 3, and 3 times negative 3 is negative 9. Denominator, 3 squared is 9, 9 times 3 is 27, so the bottom, first number is 27, plus 1 times 3 is 3, minus 75. And we are reaching the end, yay. 25 minus 81 minus 9 is negative 65. And then 27 plus 3, remember to go left to right. 27 plus 3 is 30. 30 minus 75 is negative 45. Obviously, we want to simplify that. So, let's see. 5. 5 goes into this 13 times. 5 goes into 45 9 times. and it turns into a positive answer. So there is the slope, 13 knots, which is approximately 1.44, but I would just leave it as a fraction. 13 knots is the slope for this huge problem. Okay, so again, what you've learned today for the video is how to do implicit differentiation. Make sure you do understand the difference between these two forms, implicit, explicit. This is what you've been used to most of your life. That if you have a choice between those two, of course you want to do explicit. For some problems you can't, so you have to learn how to find the derivative. Please differentiate both sides of the equation with respect to x. Collect all your terms with y prime on the left side. After that, factor out y prime and then solve for dy dx.